Alright, so now let's continue with the graph. So I'm working in the graph of type T class. So this graph just represents a graph data structure. So we're just gonna create some points somewhere. We can try to make it into a network if we have time. But you can make it into an unordered or unordered graph really easily. It doesn't matter which one. It's just a quick change. And we'll just start with the instance data. So we'll say protected final int default capacity. We'll set it equal to 5 just because we'll just make a small one first. Then we'll say protected int num vertices. We'll just leave that as null. And we'll say protected boolean. This will be a two-dimensional array, or they call it a matrix. We'll call it ADJ. So adjacent matrix. You can call it whatever you want. Matrix, OBJ, it doesn't matter. Matrix, whatever. We'll create another array here. Protected T array vertices. We'll call it vertices. And protected int mod count. We'll keep a count for mods, and protected int edge count. We'll set edge count to 0. Whoops. So here, we'll just do some doc for creating an empty graph. We'll call our constructor we'll call our class name for the constructor. So it sets up the instance data for our graph object. So all of these fields will get set up. Well, not all of them, but the ones we want to set up. So we'll set num vertices. We could have set edge count to 0 in here, but that's fine. It's already set to 0. So we'll say num vertices points to 0 or equals 0. This dot adjacency matrix. This dot vertices. This dot vertices equals. Sorry, we'll go up here first. So this dot adjacency matrix. So we're gonna instantiate our array here to a new array of Boolean objects. We'll call it we'll pass in the size to be default capacity. For the first, I think it's how does this work again? Rows by columns, right? That's how it works. So I think it's rows by columns, but we can test that out. I don't think it's columns by rows. So it's like x times y, right? In these square brackets, x times y, or x by y. But I think the x is rows and the y's columns, but we can double check that later. That's fine. So we'll say default capacity. What's wrong with this? So we'll just create another box here, another index for columns. Then we'll say default underscore capacity. So our two-dimensional array will be size of 5 by 5, which is 25 indexes. So it'll be 5 down, and then 5 across. So it's gonna look like one level. So the first level has 5 on it, next one has 5, next one has 5, next one has 5, next one has 5. So I haven't done 2D arrays in a while, but it's not that hard. Just use the debugger if you get stuck. There's a few tricks to print it out. You need to put some special spaces and stuff, but we'll do that after. So here we'll say So this one was a boolean, just a boolean. There's no type T, so this adjacency matrix or 2D array, it's of type boolean, so we can just instantiate that without casting it to an object. And then here it's a vertices array is a T array, so we're going to need to cast it to a T array to a new object. Of capacity, default capacity, so that's the size. You could have just called that anything like array size or whatever. That's fine. Alright, so that's our constructor. So you can suppress these warnings like this, suppress warnings. That should take that away. Then put unchecked here, and that'll go away. So here we'll say adds a vertex to the graph, expanding the capacity of the graph if necessary. It also associates an object with the vertex. We'll say appparam vertex, the vertex to add to the graph. So we'll say public void add vertex, and then it takes a T vertex as a parameter, so it's going to take a vertex to add to the vertex of type T, so we can add pretty much anything to this vertex. We can probably just name it with a string, like A or B, just for examples purposes, or we can put a number like 1 to 2. Doesn't matter. So actually we might need to expand. Do we implement this interface? No. So we're supposed to implement graph ADT of type T. So we'll do that up here so we can come back and do those methods. Like expand capacity, we'll do it after we do the add. Just because you know what that does at least. Like we're just going to make the array bigger. We've done that method before. So no need to worry about that too much. We'll come back. Alright, so we'll come back and do the expand capacity method after you've seen what it is before. We've done it a bunch of times. We're just doing the same thing, really, that's it. So up here we'll say implements graph ADT of type T. And if you haven't seen it, I recommend watching the videos, the whole series, if you have time, because we use those classes. In this one, we're supposed to use a list that we made, like a linked list, but or an array list that we made. But we're not going to do the traversals, like the breadth first traversal and the depth first traversal, because those are really long. It's like those are like a couple hundred lines each. We're just going to print out. That's just used to print the array out. Technically, it's used to check if it's complete, maybe connected to. We'll see. So for us to check if our graph is to check for a graph if it's complete, then we have to do special calculations. But it's nothing too bad. Like for example, a complete graph with n vertices requires n times n minus 1 divided by 2 edges to make the graph complete. So that we can probably just create a method to do if we really needed to. I can put that down here. Have it on like a little piece of paper actually. So it says I think it's directed, undirected. It says undirected, but it might work for a directed. It might work with an undirected as well. But we can check that later on. But we'll just say that an undirected graph. So down here, yeah, we'll do that here. So an undirected graph with n vertices, so n number of vertices, requires, so the formula, we'll just put it here, n times n minus 1 divided by 2 edges to make complete, to make the graph complete. We'll just say graph complete. So that's it. It should work. I'm thinking if that works for a directed as well. I can double check that later on because I'll have to open my textbook and check that out. Let me just see if there's anything else in here. So a directed graph is connected. So that was complete. So a directed graph is connected. So sorry, an undirected graph is considered connected if for any two vertices there is a path between them. So that's the one that's gonna need the traversal to check, I believe, because you have to. Unless you, well, we could do that differently. We'll get into it after. So let's just continue and see what we have for now. And if we need to add anything, we can just add it later if we have time, or if not, it's not too hard to do. So add vertex here, we'll just say if num vertices plus 1. So if num vertices plus 1 is equal to adj matrix dot length, adjacency matrix dot length. Then we'll say expand capacity. That's a method we'll do after. Actually, that's not even in the interface, but that's okay. Here we'll say vertices array of index num vertices. Whoops, num vertices points to vertex. So our num vertices is up here. Num vertices is set to 0 for index 0. So we're going to say, okay, well, the index of at this time 0 will point to, so vertex of index, sorry, vertices array of our array index 0. So that index 0 will point to our vertex object that we're going to store in that array. So basically, the vertex point will probably just store like a string or a number or something, probably a string. And that's it. Num vertices is num vertices. Yeah, so num vertices will get incremented at the bottom to keep track. It's kind of like a top or a count. Not a top, but like a count. It kind of works like top, but backwards. Top is from the linked, no, sorry, not linked, from the array stack. We did that a while ago. So then we're say for int I points to 0, I is less than num vertices, I plus plus. So this is just a standard loop through an array. So for I is equal to 0, the first index, I is less than, actually num vertices, so not through the array, we're just going to index through a certain position, through a certain index. So the first one probably won't execute because num vertices is 0 at this point. and we will then continue down here to set the adjacency matrix of index num vertices and I. So it's going to loop through this to set the R values to false. I think they're set to false initially. We can double check that when we debug it. And then the next one will get set to false false as well. So adjacency matrix of array index I. And then this column, or the row and column, will be num vertices of index num vertices. So adjacency matrix of index I and then of index num vertices is equal to false. Then we'll say num vertices plus plus. Wondering if those should be set to true, but if it's if it needs fixing, we can come back and fix it. So then here we'll say mod count plus plus. So what's really happening here is our adjacency matrix is going to store our it's going to store whether there's a edge there. So I believe right now we're just adding the vertex. So we're not going to update the edges. That's probably why it's being set to false. That might be extra. Don't worry about it. We'll if it works, what would happen there? If it works, it works. If it doesn't work, then we can fix it. Sometimes you may have extra steps in your code just for no reason, but if it works, it works. Unless you're trying to make it as efficient as possible, you can come back in and take stuff out that you don't need, stuff like that. So anyways, that's done. So I have two add edges here. One inserts an edge between two vertices of the graph. Actually, they both do that. One requires a get index. So I have a method called get index. Okay, so I believe, okay, so this is what's going to happen. So we have an edge that adds, so we're going to be able to add an edge between two actual elements, two objects, and then we can add an edge between two indexes. So it's overloaded, so that's the difference between them. I'm just looking for that other private method I have, get index, somewhere here. Span capacity get index. Okay, here we go. So let's write that one because we're going to be using this one. We could have made it private, but that's okay. So we'll say returns the index value of the first occurrence of the vertex. So we're going to return the index value of the first occurrence of the vertex. That's all we're going to do. So it'll return -1 if the key is not found. We'll say at param vertex, the vertex whose index value is being sought. Whoops. Then here we'll say at return the index value of the given vertex. Excuse me. So we'll say public int get index. Actually, we'll take a vertex and we're just going to return the index. So we're going to use a built-in method here. So we're going to have to import java.util, I believe, .arrays at least. So we'll say for int I, whoops. So we'll say for int I equals to 0, I is less than num vertices, I plus plus. We'll say if vertices of array index I dot equals vertex. We'll return arrays dot as list. So returns the array as list, as a list. We'll say we'll pass in vertices and then dot index of. Did it take a capital O? Yes, I thought it did. Vertex. That's it. So this, I'll just write what it does. So we'll say return return to, I don't know what I wrote here before as a note. Hopefully it's right, proper grammar. So return to built-in method. Return to built-in method. Return to built-in method. Returns, I think it's just supposed to say returns built-in method, returns array as list to access index of vertex method. As list returns, let me see what I have here. A fixed size list backed by the specified array. So it returns a fixed size list. That's all. Hopefully you can understand what I wrote. I think it just says, it's just supposed to say this. Probably just a typo. So built-in method. So this is a built-in method. We know what index of does. It just returns the index of the value. It returns it as a list. So it returns the array as a list. The vertices array as a list and gets the index of the vertex we're looking for. That's it. That's all it does. It's kind of tricky, but that's fine. It's a little trick, something you don't use too often. That's okay. This method, at least. So other than that, we'll just go down here, return -1 if it's not located. Alright, so let's go back to the top and we will continue with the rest of the code. Alright, so we'll go to add edge, Probably we won't need all of these, but we'll just probably do them. Excuse me. Alright, so we'll go down here. Actually, no. We'll go below this method, add vertex. So we'll say inserts an edge between two vertices of the graph. So at param vertex 1, the first vertex. At param 2, the second vertex. So say public void add edge v. I guess it adds a vertex. Or takes a vertex, so t vertex 1 and t vertex 2. So it's going to add an edge between two vertexes. And we're going to call the add edge, and I'm going to confuse you guys here, so let's do this. Let's comment this out for a sec. And we'll do, I did these in the wrong order, so we'll go down here. We'll go down just below it and we'll insert an edge between two vertices of the graph. Sorry, yeah, insert an edge between two vertices of the graph. And we're going to do that with an index. So we can just, we'll just do a little doc here. So we'll say insert an edge, because this is an overloaded method, so that's why we're having two here. So we'll say insert an edge between two vertices of the graph at param index 1, the first index, at param index 2, the second index. So here we'll say public void add edge. Take an int index 1 and an int index 2. Do we have indexes valid? Nope. We might have to do that again. Apologize. Where is that method here? This is a pretty big code, by the way. Getting into that tree level. The tree size, I mean. Alright, let's just quickly do that index is valid method. So let's just comment this out again. Apologize for that. Unless I could do it, but then you wouldn't really understand what's happening. So we'll just do it down here. We'll say returns true if the given index is valid. We'll say param index, the index where valid entity is being queried. Spell that wrong. Valid entity, okay. Spell that wrong too, queried. Forgot how to spell. 2 R's, okay, so we'll do return true. We'll say, whoops. I actually can't spell anymore, by the way. I used to be such a good speller, then I just stopped writing essays and then I just totally forgot how to spell. So we'll say here at return true if the given index is valid. Because in university, like if you're not an English major or anything or an arts major, you only have like 2 English classes and then you're done. So I haven't written anything like that in a while. So protected boolean. Index is valid. That or I'm losing my memory. So we'll say index is valid, int index. So it just returns true if the given index is valid, and takes up index to check, and then it returns true if the index probably contains something. Actually, no, sorry, we're gonna check not if it contains something, if there is an index in the array. So we'll say if excuse me. So we'll say if index is less than 0, throw new array index out of bounds exception. You should have seen this one before. It's a built-in exception. And we'll say if index is less than num vertices, return true. Else, we could have done this differently. Well, I just did it this way. Else return false. You could have said like if returns true if index is less than num vertices, but it's fine. It's good practice just to change it up once in a while. Personally, this comes more naturally anyways. If return true, else return false, so that's fine. Whatever you feel comfortable with, you can do the shortcut version if you want. Alright, so we'll go back to our methods. Just to double check here, so if index is less than 0, it's not in the index. It's not in the array. Probably if it was greater than, we could have thrown it too. But if it's greater than, it's going to expand capacity anyway, so that's fine. So we'll say if index is less than probably the num vertices. Okay, so it's saying which index is currently full. That's what it's checking for. If it's null full, it's going to throw a null pointer, right? So that's why it checks automatically. Return full, so that should be good. Hopefully you understand what's going on, I'm not confusing you. So here we'll go back to, which one were we at? This one, right? So I'll just do that with control and backslash, or forward slash, the one beside the shift with the question mark, in IntelliJ at least. Then here we'll say, which one is this? Add edge. Where are we at? Add edge, okay, this one takes 2 indexes, so we'll say if index is valid, pass in index 1, and index is valid, index 2. These are probably just extra methods, we didn't need to do these. So this is like half my code and half the book, so I kind of took what the book was starting and just finished it. In the link graph, I just did it myself, so a lot of these methods are just extra methods. You could have done it probably easier. We could have just had one big add edge and one big add vertex with just like if and else, without any private support methods, but that's fine. So if index is valid, checks if index 1 is valid and index 2 is valid. Do I need... That should be good. I feel like those parentheses are off, but that's fine. So we'll say adj matrix, adjacent matrix of index 1. So we're adding an edge here, right? So we're going to set the indexes to true now to show that there is an edge at that point. So we're going to set them to true. I believe you can also set them to like colors or something. So we'll say index 2 and index 1 points to true. So we're going to say, okay, if it's a valid index, adjacency of matrix index 1, so array index 1, and then adjacency, so adjacency matrix index 1, index 2 is set to true. So think of it like a coordinate point. That coordinate point is going to be set to true. That means there's an edge here. So this is unordered. This is unordered. So because we're doing the symmetrical of it, so if it's like 1 and 2 is set to true, then 2 and 1 is going to get set to true. Sorry, this is unordered. Yeah, so unordered is going to be symmetrical. If this was just an ordered graph, all you have to do, I believe, is just comment at 1, and we could just say, well, there's just a point at index 1 and index 2, but not a point at index 2 and index 1. So this would be unordered. Sorry, did I call it ordered? I think it's called undirected. So this would be directed because there's only a point at 1 and 2, but not the other way around, not symmetrical or not vice versa, right? But if this was undirected, then there would be a point at 1 and 2, and then the symmetrical 2 and 1. So we'll keep it unordered for now, or undirected, sorry. That's it. We'll just update our counts. We'll say mod count plus plus. So how can we turn this into a network? Well, we'd probably change the array to not a Boolean, probably to a string array. And after that we would say well, we could say that like index 1 and index 2, we could set it to like a quote. We could set it to a string, right? We could be like true. Then we could be like, maybe we could put a comma there, or we can just put true and no comma, whatever. Or we could do like that. We could say that, okay, well that distance between those networks is like 10. Would that work? We could try it out. We could test it out after if we have time. So all we're saying is like, so again, you can make networks undirected or directed as well. So it doesn't really matter how you do it as long as it works. So if adjacency matrix have index 0 and index 1, so from index 0 to index 1, it's connected because it's true, it's connected. So at that point it'll be like, okay, well it's true and it's going to store a value. Yeah, that should work. And if it was undirected, we could do the same thing here for an undirected network. And we could say that it's the same distance both ways. So can I draw a little diagram here? Let's say our first coordinate or vertex is called A, and it's undirected at this time. So we'll say the second vertex is B. Then we'll be like, okay, well the distance here is 10. That's undirected, so it's both ways. A to B is 10 and B to A is 10. Well, we don't want it to be undirected. Sorry, did I mix those up? If I mix those up, I apologize. So we'll say, okay, well we want it to be directed this time. So we'll say, okay, well we're going to say that there is an edge there, that's what the true is for. There is an edge here, that's what the true is for, but we're going to say, okay, well we want the distance to be different on the way back. So we'll be like, okay, well, the network between like Toronto and New York is like 10 from Toronto, let's say, or something that starts with A, like Alabama or something, to B, like the Bay Area in California. Let's say that it's like 10, and we'll say that the way back from the Bay Area, for some reason, it was less, or yeah. So we'll say that it was less. I'll just move these over here. And on the way back, because this, then it's 8. But usually you try to put some kind of arrow. Maybe we could be like, okay, well, true, and the direction's going this way. Something like that. Like a little arrow like this, maybe. And it's 10. And okay, well, the direction this way is going this way. Something like that. I mean, overall, I think if you're saying if there's a edge at 0 to 1, then it should be going from 0 to 1. Then here you would say, okay, well, the edge is from 1 to 0. So this first one is 0 to 1. So it's going this way. But you can accentuate that and just be like, okay, it's going this way. And then for this one, you can be like, okay, well, just to show or to prove that it's going this way. Just to help. I mean, that should work. It shouldn't be anything wrong with that. Honestly, if you're gonna do that on an exam or something, it would be, I mean, it's a good idea. It's not like it doesn't work. As long as it works, right? I mean, if you really wanted to, you could maybe store it. You can maybe store another kind of value in the array. But honestly, that would work, so I just leave it at that. So hopefully that helps you. That's probably the most we're going to do for that, if you really wanted to change it up. And we're going to be doing that in a length graph as well. Something like that to show how to do it. What's wrong with this now? Oh yeah, so it's not a string. So we'll take those out. Sorry, I got a stuffy nose again. Always have a stuffy nose. I think it's like 1 degree or less today, so in Celsius. It's pretty cold. Alright. So let's continue with the next method. So we have add edge, and we'll probably do the add edge between the vertex. So this one was between indexes. So we can add edge. We'll go back to this one and add edge between vertexes. I'll just take those, which is Control/. For a minimum spanning tree, by the way, I think you can just take the same graph and make it smaller or equal to. So you can have like less vertices and edges. I think that should be fine. That should satisfy a minimum spanning tree, I believe. So you can check the definition on that. So we'll just finish this method here. We'll say public void add edge v t vertex 1 t vertex 2, and we'll say add edge get index of, we'll pass in vertex 1, and then we'll pass in here get index. We'll pass in vertex 2. That's done. So we'll go down and we'll do the remove vertex and remove edge. Expand capacity. Size is empty. Is connected requires the traversals. I could show you how to do it. 2 string, and that's about it. We're done. So we'll just continue with these. I might have to split these up into maybe another part. Been doing it. We've been going for maybe an hour now. Okay, let's go down here. So we'll do the removes. There's about 4 or 5 of them. Not sure why there's 5. There should be 4 of them. Remove edges and remove vertex. Maybe, okay, maybe because you can remove all the vertexes, or you can just remove one of them, I think. So we'll go with this one, removes a single vertex. Removes a single vertex with the given value from this graph. We'll say that it's the first occurrence. We'll say at param vertex, the vertex to be removed from this graph. So we'll say public void remove vertex v, we'll call it remove vertex v, we'll say t vertex. We'll set boolean found to false. Do we have remove edges? We'll just do this here just to for an optional. So we'll say you can remove the edges of the vertex parameter here, optional. To remove edges associated with vertex, that's optional. So then below here we'll say for int I is equal to 0, I is less than num vertices, okay. I is less than num vertices, I plus plus. So we're going to iterate through the array before the, just to the index that's full, I guess. The last index that's full, then we'll say if vertices of array index I dot equals vertex. So this graph is really just about thinking. So I know that sounds broad, but you can just really just say, okay, well I want to put a point here and a point here and put an edge there. So you can do that any way you want, really. That's what I kind of was finding for this, like when I was doing the assignment. That you can just use, you can be like, okay, well I'll show you, like we're just going to create a graph node later to do links where we're going to set some pointers. But all you have to do is connect one point to another point, maybe make a third or a fourth, and be like, okay, well I'm going to connect those, we're going to make it undirected, so it works all the way around. or we're going to make it directed, it works only one way, or we'll turn it into a network. So it's not that hard, you just have to implement it how you want to. So arrays can be good, 2D arrays. You can probably do this in a different way, right? You don't have to create like a adjacency matrix array to show where the points are. You can perhaps just store them at certain indexes. Like there's different ways to do this, right? So anyways, here we'll just say if vertices of array index I equals to the vertex parameter. Then we'll set found to true. Then we'll say vertices of index I points to null. Then we'll say num vertices minus minus, or decrement by 1. Then we'll say mod count plus plus. We'll increment mod count by 1. Because remember, on a remove you should increment the mod count by 1 as well. Then we'll use a break there to break out of the loop. And then here we'll say if not found. Do we have a found? Yeah, so if found is equal to false, that's what it's saying. Yeah, because if we were saying found, then we'd say, okay, well, if found is equal to true. So that's a shortcut version. So here, if found is equal to false, that's all it's saying. And you could have also said this here, if found is equal to false. That works too. This works as well. Whatever you like. So then here we'll say system.out.println. I think you can use that in like JavaScript and stuff too. Not found and found. So system.out.println vertex plus not found. So that's it. Just a formatting string here to say that the vertex was not found with a concatenation. That's it. So you got like 4 more to do of those. I'm just gonna have a sip of water here. Alright, so I might come back and do like a part 3 for the iterators at a later time. At this point, I'll just tell you how to do it, like how to do is connected. And if I have time, I'll make a video on that, because the iterators itself are like, it would be longer than the tree, I think, the tree video. So it's a big one. So here, I think there's probably an easy way to do it. The way you have to do it is check if each vertex is connected to either one. So if there's 5, then you go like 0 connected to 1, 0 connected to 2, 0 connected to 3, 0 connected to 4. Then the next one you'd be like, okay, well, is 1 connected to 0, is 1 connected to 1, is 1 connected to 2, 1 connected to 3. You know what I mean? 1 connected to 4, 1. So yeah, so then we'll say, okay, well, is 2 connected to 0, 2 connected to 1, 2 connected to 2, 2 connected to 3, 2 connected to 4, and then all the way to 4. So 5 times what? 1, 2, 3, 4, 5. So maybe it could be 25 different possibilities based on that, and that's what you have to do. And you could probably implement that with an easier way. Like you could check for an undirected. You could be like, yeah, is 0 connected to 1? You could set it to true. Is 0 connected to is 0 connected to 2? You could check true or false. 0 connected to 3. 0 connected to 4. Is 0 connected to itself? Well, you don't really need to do it yourself. Excuse me. So 0 to 1, that's 1. 0 to 2, that's 2. 0 to 3, that's 3. 0 to 4, that's 4. So maybe 16. You have to check. That's for only 4 vertices. I think that should be right. 0 to connected to 1. 0 to connected to 2. Because if you have a box, where should I do this? Maybe down here. Okay, let me go down here. So this is for the is connected method. You have to check if your graph's connected. So like this is connected. So if we have a diagram, I'll try to do less. So it'll be like A to B. We'll do 3 points. How can I do 3? Okay, so we'll do here. Be like, nope. Be like down here, C. It'll be a little tricky, but we'll go like this. Whoops, no, C. And we'll say, okay, we'll have some points like that. Now, what can I use here? What's a good symbol? That, okay, so shift, backslash, whatever. Forwards, yeah, backslash. And then how can I draw the line to there? How did I do this before? Okay, let's just do 4 of them. Forgot how to do that. So A, B, C, D, and there'll be one of these symbols down here too. Okay, so this is a, let's say it's an undirected graph. If it was directed, we'd put points here. If we want networks, we'd put numbers above the points to have triples each way. Alright, so is connected. So we have to check, I got my definition here somewhere. An undirected graph is considered connected if for any 2 vertices there is a path between them. So if for any 2 vertices in the graph, so is A connected to B, this is going to be hard doing it that way, so let's do it. 1, 2, we'll say we're storing numbers in our string, so 1, 2, 3, 4, just for example purposes. So we're saying, okay, well, maybe just change this to 0. 0, 1, 2, 3. So okay, well, is 0 to connect it to 1? So what would we need here? What would we need? We have 0. We have 1. We have 2. We might need some kind of graph, some kind of column, maybe an array, an extra array, to check if it was just in this. It's just maybe like a what's it called? Local array for that method, something like that. So it'd be like, okay, well, 0 connected to 1. It is. Is 0 connected to 2? It is, because for 0 to 1 we can go this way in our graph. Is 0 to connect it to it, since it's undirected, well, we can go this way as well. We can go right, or we can go down, right? So that works. Is 0 connected to 3? Well, we could get there both ways. We can go this way to get to 3, right? Take that path, or we can take this path. So it is connected to 3. So 0 is connected to 1. So that would be true. 0 connected to 2. That would be true. That 0 connected to 3. That would be true. So that's 1. Maybe do like this. 0 is connected to 1, 2, 3. So that's 3. So for the next one, it'd be like 0. Maybe do like 1, 0, 2, 3. Like that. So we start at 1 this time. Well, is 1 connected to 0? It is. Is 1 connected to 2? It is, because we can take this path. Is 1 connected to 3? It is. We could just take that path. 1 connected it to itself, basically it is. Then for the next one, you get the idea, hopefully. Hopefully I'm not confusing you guys, so just take 2 here, we'll do the same thing, 0. So we'll say 2 is connected to 0, 2 is connected to 1, 2 is connected to 3. So is 2 connected to 0? It is. 2 connected to 1? It is, because there's a path this way. And this way. We're undirected. And is 2 connected to 3? It is. It's right there. Or you can go all the way around. So that works. So can we just use some kind of... We could make probably a simpler loop to check this. But the problem is, if you have like 100 elements, it's going to be massive. And you have to make sure it works. I'm sure you could do it. The way I did it was with a breadth first traversal. That's just the way they taught us, or a depth first traversal. So it uses an iterator to do some code to check. You could probably be like, you could probably use a 2D array to do this, right? We'd set it up somehow like this, and you could do it. It'd just probably take a while to implement, so I'll just leave you guys with that. You guys can figure it out if you need to do that. You just use a loop. Honestly, you could use a 2D array and a nested loop. We'll be doing a few of those above. And you just be like, okay, well, for I is, let's do the matrix loop. For I is equal to 0. You could honestly just set them up like this. 0, 1, 2, 3. Check, you could keep it the same. 0, 1, 2, 3. 0, 1, 2, 3. It shouldn't be too hard to do. 0, 1, 2, 3. Probably the same way we're going to be doing some of this. So we're going to be like, okay, well, if there's an edge, or if there's a path from 0 to 1, that would be true. If there's a path from 0 to 2, that would be true. If there's a path from 0 to 3, that would be true. So as long as there's a path for each way, then you could just set it to true. So maybe if there was like 9, so it's complete. So we could use our formula here maybe. What was the formula? Did I put that up? Yeah, I put it above. So an undirected graph is complete if it has those. If it has the n minus 1 divided by 2 edges, right? So that should work. Otherwise, you can just check if you can create a formula yourself. Well, let's say it's an undirected graph and you have 4. Because look, 0 to 2, 0 to 3, I mean, you can create a direct link there if you wanted to, through the middle. And if you wanted 2 to 1, you can create a direct link there to have extra links, but you don't need them. So you could just create a 2D array to check if there is an edge there, then you can set them to true. And for each for an undirected graph, mostly it should work, because even if you have like a strange shape, you should be able to check. But anyways, well, I'll try to add that method later. So let's just continue with the other methods first, and we can come back to that later if we have time. So we did remove vertex, passing in a t vertex. Hopefully I didn't confuse you guys there. Don't worry about it, we'll come back later. So we'll do public void remove vertex. We'll pass the index this time. So down here, public void, okay. So public void remove vertex. We'll pass an int index. We'll say if index is valid. So if index is valid, of index as a parameter is equal to false, and we'll system.out.println index is not valid. Equals not removed, so this is just a string, and we'll return. So you could probably just throw an exception there if you want. something, anything you want. You can return null, whatever you want. So here we'll say t-val points to vertices of array index. We'll say for I is for int. Nope, yeah, for I is equal to 0. I is less than vertices. Oops, for I, that should be for int I. For int I is equal to 0, I is less than vertices. Dot length. I plus plus. If vertices of array index I dot equals to val, vertices of array index I set to null, system.out index as a string plus index plus removed. It's going to tell you that it was removed, and then we'll set num vertices -1 or minus 1. We'll increment mod count by 1, and then we'll break out of the loop. So that's it. Did I do some doc for this? I did not, so let's just go up for that. From that, where are we? Actually, I don't even have any doc for this, so that's okay. So it just removes a vertex from the index. What to say? It removes vertex based on index. Something like that. Alright, after that, so that was remove vertex. How many more do we have? Remove edge. Okay. So this is a method, extra method I created, so we'll just do, this removes all the edges. So any edges connected so it's any edges associated with a specified vertex. Basically anyone that connects to the vertex. So we'll say add param vertex, and this one uses the 2D array loop, I think. Is it? No. Oh yeah, it does. So I don't think we've done that yet in a while, so we'll say public void remove edges t vertex. We'll say int edge mods equals to 0. Int val points to get index, pass an index, vertex, sorry. For int I is equal to 0, I is less than AGJ matrix dot length I plus plus. So this is a nested loop to print out a 2D array, I think. Or so for this, here we'll do for int j is equal to 0, j is less than ADJ matrix array index I dot length. That's the trick you have to do. Then we'll do j plus plus. We'll say if ADJ matrix of index array index I and then array index val is equal to true. We'll say ADJ matrix of I to val, or sorry, array index I, and then array index val. Array index I and then array index val is set to false. Then here we'll say if ADJ matrix of index val to index, index val of then index j, array index j. So ADJ matrix of array index val, array index j is then set to true. Sorry, if the array index val and array index j is equal to true, then here we'll set it to false. ADJ matrix of array index val, array index j is set to false. Edge mod plus plus. That's all. Oh, nope. Sorry, it's not all. There's a few more lines here. So 1, 2, 3. So here we'll say system.out .print line edge count plus edge count. System.out .print line edge mods plus edge mods. Is edge count from above? Yeah, it is. So that's our global variable, edge count. And edge mods, and then we'll say edge count points to edge count minus edge mods. Edge count points to edge count minus edge mods. System.out.print line updated edge count plus edge count, and we'll say mod count plus plus. So that should be correct. Hopefully, if we don't have any mistakes, we can come back and get them later. Might be taking a break here for lunch and coming back. Not at this second, but we'll do a few more. So what do we have for now? We have a remove edges, so we remove all the edges associated with a vertex. We can remove one vertex based on index. We can remove one vertex based on the vertex. Probably won't need all these, they're just extra methods that I did. So remove edges. We'll have two more remove edges actually, between two vertexes and between two indexes. That should be most of them, and then we just have the extra easy methods, stuff like that, and maybe the is connected as well. And then of course we'll do a few tests, so I'm thinking another hour at the minimum. So we'll say remove edge v. So this one, yeah, so we'll go on to the next method here. So we'll say removes an edge between two vertices of this graph at param vertex 1. Excuse me, the first vertex at param vertex 2, the second vertex. And here we'll say public void remove edge v takes a t vertex 1 and a t vertex 2 we'll say int val1 points to get index passing in vertex 1, and then here we'll say int val2 points to get index passing in vertex 2. We'll say if val1 is equal to -1. I think if it was not found, if val1 is equal to -1 or val2 is equal to -1, well, system.out.print ln vertex 1 and or vertex 2 not located. This just reports it to the user return. Otherwise we'll say adj matrix of val1, index val1, array index val1, and adj matrix of array index val2 points to false. And here we'll say adj matrix of val2 and adj matrix of val1 set to false. So if you were just doing this as in directed, you could just set one of them to false, whatever you want, right? We went over that, and you would have to probably set them to null if you're using a Boolean array and you're implementing the networks as well. So you'd probably just set them to like null or empty space, whatever. There's a mistake up here. I think I said int, it should say if. This one stays there. So we'll do edge count minus minus, decrement by 1, and then here we'll say mod count plus plus. Alright, so I'm just going to take a little break and I'll be right back. So see you guys there.